Here we're going to go over putting our knowledge of all the characteristics of rational functions together so that we can sketch an accurate graph. We're going to start off by finding the x-intercepts by setting y equal to 0. So when I do that, I've got 0 equals 5x minus 3 over 4x plus 9. When I do this, it's equivalent to just setting the numerator equal to 0, which means that I have a linear equation that I can solve for x, which is going to give me my x-intercept of 3/5 and 0. The next thing I'm going to do is find the y-intercept, so I'm going to set x equal to 0, which means that I'm actually plugging in 0 where the x is, and I'm going to evaluate it. Here I'm going to get a value of minus 3 over 9, which is the same as minus a third, which means that my y-intercept is 0 minus a third. The third thing that I'm going to find is my vertical asymptote, which are the zeros of the denominator. And what that means is I'm going to set the denominator of my function equal to 0, and I'm going to solve to get the equation of my vertical asymptote. Once I have that equation, now I need to find my end behaviors. And in order to do that, I am going to check a value that approaches my asymptote from the left and the right. Now, I'm going to change minus 9/4 into a decimal so that it makes it a little bit easier for me to visualize. 9 divided by 4 is 2.25, which means that as a decimal, I can also visualize this as minus 2.25. So I'm looking for a value as x approaches minus 2.25 from the left. I want to know what is happening to my function. And the value that I'm going to test is minus 2.26. It's a little bit further to the left on the x-axis. So when I do that, I am actually going to substitute in that value into my original function, and I'm going to calculate it. So I've got 5 times minus 2.26 minus 3 over 4 times minus 2.26 plus 9, which is going to give me a value of 300, I'll say approximately, 357.5. I know that that is a positive number, so I can say that my function is going to positive infinity as I approach my asymptote from the left. I'm going to repeat the same process, except I'm going to test a value that is on the right-hand side of that asymptote. So as x approaches minus 2.25 from the right, I want to know what's happening to my function. And so I'm going to test x equals minus 2.24. So that means I'm actually going to substitute into my function just like I did before. I'm going to use my calculator, and I get a value that is about minus 355, which is a large negative number. So that means I can infer that my function is going to approach negative infinity as I approach that asymptote from the right. The last thing I need to check are my horizontal asymptotes. Horizontal asymptotes are the ratio of my largest degree coefficients, and they are always a horizontal line. This time I've got 5 over 4. And then I also need to check my end behaviors. So this is also called the large number test. So I need to know as x goes to negative infinity, what is happening to my function. And then as x is going to positive infinity, what is also going to happen to my function. So I'm going to pick a test value that is first a very large negative number. And we're going to use minus 100. And what I want to do is I'm actually going to put that into my function. So f at minus 100, I'm actually substituting that in and evaluating. The brackets are important. And when I do that, I am going to get a number that is 1.286, we can identify that 5 over 4 is the same as 1.25, which means that this number, 1.286, is slightly above that value. So I know that my function is approaching my asymptote, 1.25, from above. I'm going to repeat the same thing. So as x approaches positive infinity, I'm going to choose a large number. I want to know what's happening to my function. And I'm going to test x equals positive 100, which means that I'm actually going to substitute it in. When I do that, I'm going to get approximately 1.215, which is below. So that now I know that my function is approaching my asymptote from below as I get up to large values of x. So now I'm going to go and sketch my grid. First thing I'm going to put on is a scale, some sort of scale here. So 1, 2, 3, 4, just to give me an idea of where I'm going. Then I'm going to put on my x-intercept. So my x-intercept is 3/5, which is somewhere in between 0 and 1. So let's put that right there, my x-intercept. My y-intercept is -1/3. So that is somewhere here in between 0 and -1. I know that my y-intercept is at -2.25. So that is, there we go, a little bit to the left of my -2. And then I'm also going to put on my horizontal asymptote, which is 1.25 or 5/4. So let's put on -2.25, which is right over here. I'm going to use a dotted line, and I'm going to label my asymptote. I'm also going to put on the horizontal asymptote at 1.25. Again, I'm using a dotted line. I go all the way across the graph, and I'm going to label my asymptote. Now, the next thing that I'm going to do is I'm going to apply my end behaviors to those points. So I know that as x is getting really large, so that means that as I'm traveling this way on my x-axis, my y values are going to approach that horizontal asymptote from below. So that means that my graph is going to look like this here. And then I know that on the right-hand side of my vertical asymptote, which is right here, my function is going to -infinity. So I can tell that I'm going down like this and approaching my asymptote. Then on the opposite sides, I know that as I approach my vertical asymptote from the right, I'm going up to positive infinity. Up here, I've got my end behaviors. As I approach my asymptote, my function is going up to positive infinity, and then I'm going over this way. And that is how we take all of our information and put it together into our rational function graph.